9.2 homework discussion. For problems 1, 2, 3, and 4, you are just finding the partial sums. So I don't know if it came across real clear, but anytime you have a series, and I'm just writing this one that they gave us in problem number 1, that is your S sub n. So that's like the partial sum, which this isn't going to be partial for S sub n. That is going to be the total sum of the series. But if I wanted to know what S sub 1 is, that's the partial sum of just the first term. And then S sub 2 is the partial sum of the first and the second term. So if you added those together, you're going to get 4/3. S sub 3 is the partial sum of the first 3 terms. So if you added those together, you're going to get 23/15. S sub 4 would be the partial sum of the first 4 terms. And if you added those together, you're going to get 74/45. S sub 5 is going to be the partial sum of the first 5 terms. And if you added those together, you're going to get 859/495. And you could keep going, of course, but hopefully you'll start to see a trend, and there's going to be some of these that end up adding up to one specific number. But you know, you're approaching something here. So every single time you're thinking, okay, that was 1 1/3, you know, you're thinking, how much are they adding on? And is this going to go to infinity so that your series would diverge? Or is this going to get closer and closer and closer to some other value? It might be pi²/4. It might be, you know, could be anything, but it might be getting closer and closer to some value. So that's why we use all these other tests to try and figure it out. But for problems 1 through 4, we are just having you practice doing partial sums, because this will be something that you're going to be using in later lessons. Then we go to 5, 6, 7, and 8. And on those, like on number 5, it's clearly not geometric, okay? For something to be geometric, it's going to be a number being taken to an nth power, or an n-1 power, or an n+1 power. You know, it's going to be one of those, a number being taken to a power. If you notice on number 5, it's just like a linear function over a linear function. So you're going to, the only thing you have, because right now we only have the geometric series test, and we have the nth term test for divergence. So the only thing you can do is look at, for number 5, the limit as n goes to infinity of your nth term. 2n minus 5. Okay, now this is almost like 3x plus 2 over 2x minus 5. We would look at these two terms, because they're so strong. The plus 2 in the numerator, the minus 5 in the denominator are not really going to matter. So when you're taking that limit, you're basically just looking at that 3n over 2n. And of course your n's are going to cancel. And so this limit is going to be 3/2. This is the limit of the sequence. Okay? So, but they're asking us to find whether the series converges. The sequence obviously converges to 3/2. But if I'm adding 3/2, or, you know, close to 3/2, you know, continuously, I'm going to diverge as a series, right? So if you were just talking about a sequence, the sequence would converge to 3/2. But the series is going to diverge. And the nth test for divergence, states if the limit as n goes to infinity of some a sub n equals some number, then the summation of a sub n diverges. And since it did equal some number, therefore number 5 diverges. Number 6 is also clearly not geometric. Okay, it is not a number to an nth power. So again, really all we have right now is the nth term test for divergence. So we're going to look at this sequence. And again, this is so strong that your plus 1 in the denominator is not going to matter. So when you look at just the limit as n goes to infinity of n factorial over 2n factorial, the n factorials are going to cancel, and you're going to get 1/2. And so since 1/2 is an actual value, you're going to have divergence by the nth term test for divergence. Okay, number 7, similar to number 5, I think, but it has an ln in front of it. It is not geometric. Only thing we have to do is look at the limit as n goes to infinity of ln of n divided by 2n plus 5. Again, this is going to be so strong, those n's are going to cancel, and you'll get 1/2 here, and so it ends up being ln of 1/2. Or, remember, ln1 minus ln2, ln1 goes to 0, so this is negative ln2. And since this is an actual value, then by the nth term test, it diverges. Number 8, this one is geometric. Okay? When you have geometric, you want to find r. Find your r, because once you find r, you know that if r is greater than 1, it diverges. And if r is between 0 and 1, it converges, and we actually know what it converges to. A over 1 minus r. So your first term over 1 minus r. So it's very important when you see a geometric that you start trying to figure out, okay, what is happening with this geometric? Well, we have the summation from n equals 1 to infinity, and this is 4 to the n plus 1 over 5 to the n. And over to the side, we could say, well, that's 4 to the n times 4 over 5 to the n, right? So if you brought that 4 out front and looked at it as 4/5 to the n, the only problem that you have is that you're starting at 1, and so your first term is going to be 16/5. So if you wanted to do, like I had told you before, and since you've got your n equals 1 to infinity, and you wanted to make this somehow your r to the n plus 1, or n minus 1, so that this will be your first term, this will be your a, you're going to have to pull out a 4/5. Well, when you pull out a 4/5 and it gets multiplied by 4, that's going to be 16/5. Okay, so now you can see what your a is. And since your a is 16/5 and your r, so this is your a, this is your r is 4/5, so it lies between 0 and 1, so you know your geometric series converges. You're going to say since 4/5 lies between 0 and 1, summation n equals 1 to infinity, 4 to the n plus 1 over 5 to the n converges to, and then you'll do s equals, you've got your 16/5 divided by 1 minus 4/5. So 16/5 times, and then this would be 1/5 that you're dividing by, so you're multiplying by 5 over 1. The 5s are going to cancel, and it will converge to 16. So converges to 16. So now, on 9 and 10, you have to create on number 9. You need to create your nth term. Now, if you want to stop and try to figure that out, that would be great. The numerator's easy, it's 1. But you want to figure out how can, what kind of number will give you those denominators. And notice that it's increasing by 4 every single time. So you're going to be, looking for that nth term. Once you find that nth term, you're going to take the limit as n goes to infinity of that nth term. And remember, if it equals 0, if this equals 0, you only know that it might converge. You don't know for sure whether it converges. Okay, it might converge. So hopefully you either stopped this and you tried to find your nth term or something, but hopefully you found that your nth term here, 1/3 plus 1/7 plus 1/11 plus 1/15 plus ... plus 1 over 4n minus 1, hopefully you found that to be your nth term. That should give you all of your terms that you're producing here. So when you look at putting infinity in there, you do get 0. So all you know is that it might converge. You don't know whether it does or not, but you do know that this is a transformed version of 1 over n. So 1 over 4n minus 1 behaves like 1 over n. One over n diverges. Okay, this is the harmonic series. And just to remind you, I showed you, how you have 1 over n, and this is a piece of it. If we looked at it from 1 to infinity, so if we just said, okay, I would like to look at the integral from 1 to infinity of 1 over n, dn, or you could think about it as 1 over x dx, either way, and you looked at what this area under the curve is, because by definition of the integral from 1 to infinity, 1 over n dn, that is the area under the curve. Well, you're going to say the limit as b goes to infinity, integral from 1 to b, 1 over n dn is going to be the limit as b goes to infinity of ln n from 1 to b, limit as b goes to infinity, this is going to be ln b minus ln 1. We know ln 1 is 0, so that's going to go. So if I put infinity in here, I'm going to get infinity. This diverges. That means that this area just keeps getting larger and larger and larger. It goes to infinity. Then we have a very similar looking one, 1 over n squared. Well, what if we looked at that from 1 to infinity? So Same type of situation. We're looking at the area under the curve, only this time when we integrate, this is going to be, you can change that to x. In fact, I like to make it x. 1 over n, 1 over x is okay. 1 over n squared, 1 over x squared, okay. So that could have been x up here too. But look at what happens when you integrate this one. This is going to be negative 1 over x from 1 to b. So the limit as b goes to infinity of negative 1 over b minus negative 1 over 1. And so this is going to be the limit as b goes to infinity of negative 1 over b plus 1. Well, this goes to 0. So this is 1. So this one converges. But we don't have to worry about this one on this problem. We're talking about 1 over n. We know it diverges. Okay? And since this one is behaving like 1 over n, we know, so 1 over 4n minus 1 diverges. Okay, so your answer to number 9 is divergence. 11, 12, 13, 14. For number 11, I want you to use s sub n minus s sub n minus 1 will give you a sub n. And I want you to use that on number 12 also, okay? Because they asked you to find a sub n, they gave you s sub n. And to find s sub n minus 1, you're just going to put an n minus 1 in. And I think we did those in the notes. Number 13, if you want to find a sub 7, you can take s sub 7 minus s sub 6. On number 14, if you want to find a sub 5, you can take s sub 5 minus s sub 4. Okay, so you should be able to do those. And, you know, these are going to give you actual numbers as answers. And these are going to give you, you know, basically sequences or functions, right? Sequences or functions, you know, f sub n's. And then that leads us to number 15 and 16. And they want you to use partial fractions. So you're going to take your negative 2 over n plus 1 times n plus 2, and you want it to be a over n plus 1 plus b over n plus 2. So what are you going to do? You're going to take a times n plus 2. You're going to take that times that, plus b times n plus 1. Take that times that. Set it equal to your numerator. Now, if n equals negative 1, then your b is canceled out, and your a simplifies to negative 2. And if your n is negative 2, your a cancels out, and your b becomes 2. So we get a equals negative 2 and b equals positive 2. So now we're able to take our summation, n equals 1 to infinity of negative 2 over n plus 1 times n plus 2, and say, okay, I just proved that this can be written as, and I'm going to put the positive 1 first, so I'm going to put the b is 2 over n plus 2, and then minus, for my negative 1, I'm going to do it second, 2 over n plus 1. So you've just written that, because we've basically proved that these two things are equal to one another, so I'm able to say this is equal to this. Now what I would like you to do is start showing me these terms. So if I put a 1 in, I'm going to get 2/3 minus, if I put a 1 in here, I'm going to get 2/2, which is 1, plus. And now I'm going to put a 2 in, 2/4, which is 1/2, minus, I put a 2 in here, 2/3, plus. Now I'm going to put a 3 in, 2/5, minus, put a 3 into the next one, 2/4 is 1/2, plus. And I could keep going. You can keep going however long you want. But you need to start looking at it when n is n minus 2. And then you'd like to look at it when n is n minus 1. And then when n is n. Because what you're going to see is that, like, you've got 2/3 and negative 2/3. You've got 1/2 and negative 1/2. You're going to have 2/5 and negative 2/5. And it's going to keep canceling out. You know, so this one is going to go away. The one that isn't going to go away is this is not going to go away. And something else is not going to go away. We don't know yet. So let's go ahead and put our n minus 2 in. That's going to be 2 over, if I do n minus 2 plus 2, I just get n. Minus, and if I put n minus 2 into the next one, I get 2 over n minus 1. Plus, then if I do my n equals n minus 1, I get 2 over n plus 1 minus 2 over, and for n minus 1 plus 1, 2 over n. And now I want to lastly do my just my n, so it'd be 2 over n plus 2 minus 2 over n plus 1. So as everything is canceling, you can see that I've got 2 over n, negative 2 over n. I've got 2 over n plus 1, negative 2 over n plus 1. This one would have gone away with 1 before it. So this is the other thing that's left. Okay? So, and by the way, every single time that you are, every single time that you are calculating this, this is your S sub n, right? This is your S sub n. Okay, so our S sub n is now going to boil down to negative 1 plus 2 over n plus 2. So now I want to look at the limit as n goes to infinity on this negative 1 plus 2 over n plus 2. And notice that if I put infinity in here, this goes to 0. And so my answer becomes negative 1. And that is the sum of my